Okay, let's say that if we are looking at systems of linear equations where we have working with networks, and we have for this particular diagram, okay, we have referring to the flow of traffic in vehicles per hour through a network of streets, and it says to solve for the system, okay, where we have x of I, where I is equal to 1, 2, 3, and 4, and so on. And it says that if the system has an infinite number of solutions, express x of 1, x of 2, x of 3, as well as x of 4 in parametric terms, that is in terms of the variable t. And here, okay, we'll let a be equal to 60 and have b equal to 100. And so just for what we have in this particular setup, so I'm going to just use a bit of numerical marking, okay, in terms of just isolating the junctures. Okay, I'll just go clockwise. So you have juncture 1, juncture 2, as well as 3 and 4. And just looking at the pattern here, so we have for each juncture, okay, just to maintain a balance on both sides, okay, where we have what is going in and what will be going out will be equal. And so we have, let's say in the case of juncture 1, okay, so if you notice by the arrowheads here, okay, so we've got b plus x of 2, b and x of 2 are going in, whereas in terms of what is going out, we have x of 1. And again, we have b at 100. Okay, so yeah, 100 plus x of 2 is equal to x of 1. And let's say that for what we have in the case of juncture 2, okay, in terms of what is going in, okay, indicated by the arrowhead here, we have x of 4. And in terms of what is going out, okay, have x of 2 exiting, a is also exiting. And with a at 60, so we have the x of 4 is equal to x of 2 plus 60. And for what we have in the case of the third juncture, okay, we have going in, we have x of 3, exiting, we have x of 4 and b. Again, we have b is at 100. And for what we have in the case of the fourth and last juncture, okay, in terms of what is going in, okay, we have a, and what is also going in, I overlooked this, okay, so you have a going in, x of 1 is also going in, and in terms of what is going out, okay, we have x of 3. And again, we have with a at 60, so you have 60 plus x of 1 is equal to x of 3. And just taking what we have, if we set up a system of equations, okay, so if I gather, let's say the variable terms, and just have x of 1 at the front, or the lower subscripted value variable term at the front, we have x of 1 minus x of 2 equal to 100. Next setup, okay, I can say that I have x of 2 minus x of 4 is equal to negative 60. And we have, in the case of the next item, I can say that I have x of 3 minus x of 4 is equal to 100. And also gathering case, I have x of 1 minus x of 3 is equal to negative 60. And so just gathering what we have now, okay, and expressing in terms of a matrix. Okay, so we got x of 1 all the way out to x of 4. So the first equation, okay, so you have 1x of 1, negative 1x of 2. Now there's no x of 3 or x of 4 term. Next equation, we don't have an x of 1 term, but we do have 1x of 2. There's no x of 3. And we have a negative 1x of 4. We have is equal to negative 60. Next in line we have x of 3 minus x of 4 is equal to 100. And then we have x of 1 minus x of 3 is equal to negative 60. So we have 1x of 1, no x of 2, negative 1x of 3. Okay, so this is going to be the matrix originally on the basis of what we have from the defined equations. Okay, and looking at solving for all of x of 1 through x of 4. Okay, so if I get the equation after displaying in matrix form and then translating the matrix in terms of at least row echelon form. Okay, so we have here, okay, first column I want 1 0 0 0, so I can adjust the last row. Okay, so I can just take the first row elements away from the last row elements. So I have R of 4 minus R of 1. Again, so the last row is going to be adjusted. So looking at what we have here, so we got 1 minus 1 is 0. And we've got 0 minus negative 1 is going to be 1. Negative 1 minus 0 is negative 1. And we have 0 minus 0 is 0. And we have negative 60 minus 100 is a negative 160. Okay. And for what I have, again, for the row echelon form, okay, so I got 1, 0, 1, and I want 0, 0, 1, and I want to, where possible, continue out to 0, 0, 0, 1. So I had to make the 1 as well as, where possible, the negative 1 into a 0. So first things first, if I make the 1 into a 0, okay, so I can subtract, and what I can do in this case, to go from 1 to 0 here, I can just take the fourth row elements and deduct the elements from the second row. Okay, so 0 minus 0 is 0, 1 minus 1 is 0. So I want to keep things in the right direction. Okay, so we got, again, so this time we'll have R of 4 minus R of 2. And once again, it is just the last row, okay, that is going to be affected. So for what we have, again, okay, so got 0 minus 0 is 0. One minus 1 is 0. We got negative 1 minus 0 is negative 1. 0 minus negative 1 is positive 1. Negative 60 minus negative 60. Okay, that's going to be a negative 100. So again, for the row echelon form, okay, I got 1, 0, 1, 0, 0, 1. And again, I want 0, 0, 0, 1 if possible. Now I need to make this negative 1 into a 0 while keeping the first two column last row values also preserved at 0. So this time I'm going to add the third row elements to the last, And so taking what we have now and putting it in the form of RF4 plus RF3 again, just copying, and again it's just the last row that will be affected. Again, just adding together. Okay, so we got 0 plus 0 is 0, 0 and 0 is 0, negative 1 plus 1. Okay, that is going to be 0. 1 plus negative 1 is 0. And negative 100 plus 100 is going to be 0. Okay, so this is going to be the reduced form of what we have here, and in terms of what we have, okay, just for the system. So okay, so what we have for the system. So we have for the equations, okay, so you have x of 1, we can say is equal to 100 plus x of 2. And then we have the one here is in reference to x of 2. And x of 2 is going to be equal to negative 60 plus what is going to be x of 4. And we have in the mix, okay, so we got x of 3 is equal to 100 plus x of 4 and guess what we have with the last row, there's no x of 4, there's no 1 to indicate we have finite value for x of 4. In other words, no one particular value for x of 4, and this is going to be what is regarded as a free variable. And any of the variables that are free, you'll be assigning parametric symbols. Okay, so in this case, okay, we got x of 4. We can let this be equal to t. And just taking what we have in reverse, so we have for x of 3, we have 100 plus x of 4, which is going to be t. And we have that x of 2 is equal to negative 60 plus t. And for what we have in the case of x of 1, again we have 100 plus x of 2. Again, x of 2 we have at negative 60 plus t. And once you combine the constants, so you want to have in the system, okay, so you have the x of 1 equals 40 plus t. Again, we have x of 2 equals negative 60 plus t. Then we have the x of 3 is equal to 100 plus t. And once again, we had the x of 4 is equal to t. And so that will be the solution set of what we have for x of 1 through x of 4 in the case of what we have with this particular traffic system.